Hi engineers, so if you guys are back for part 2 for the muscle mechanics, appreciate it. What we're going to do now in this video is we're going to talk about, again, the strength of neural stimuli, how that's affecting the graded muscle responses. And then after that, we're going to talk about motor units, specifically the recruitment principle, based upon size. Okay, so we talked about frequency of neural stimulus and how that affects these graded responses, which can produce, muscle contraction and generate tension. Now I want to talk about the strength of the neural stimulus. So let's pretend I'm like a little lab nerd. I'm a little laboratory nerd and I'm a freak. And I got like, let's say I have a muscle here. And I want to, let's say I have like a little shocker, some type of like defibrillator or something like that. And I try to shock this muscle. Let's say I set the dial up at 10 millivolts, whatever. Okay, we're talking theoretically again. Okay, so let's say I start off. My first thing is I'm going to be like, all right, I want to see what happens to this muscle cell if I hit it with 10 millivolts. So let's say I do that. Let's say I hit it with 10 millivolts. So I shock this sucker here. I shock the muscle. Nothing happens. No response. Okay, that's interesting. Let's jack that sucker up. Let's increase the voltage to 30 millivolts. Let's hit it with 30 millivolts now. Let's say I hit it with 30 millivolts for the second time, and I notice, oh, a contraction. The first observable contraction, which is initiated by this first neural stimuli, means that I must have reached a threshold. So that must be my threshold stimulus, or my threshold voltage. So threshold stimuli. It means it's the actual minimum amount of voltage that I have to hit this muscle cell with to produce the first observable contraction. So let me put that under there, or right next to it, first observable contraction. Then let's say I decide to be a freak, and I jack this sucker up to 1,000 millivolts. All right, I'm like, you know what? I'm going to hit this sucker with 1,000 millivolts. So let's make it a different color because this should be memorable. So I hit it with 1,000 millivolts. I don't know why I would do this, but I do. All right, I hit it with 1,000 millivolts. I shock it. Boom. The muscle contracts powerfully. I'm talking extremely powerfully, and I generate a lot of tension, and the muscle shortens excessively. So when I have that, and I produce this very prolonged and very strong and powerful contraction. So let's put here powerful contraction. I noticed that. Okay, all right, well that's cool. Let me actually increase it up a little bit more. Let's say I hit it with like 2,000 millivolts for a second. So let's say that I follow this one up, and for the fourth and final time, I hit it with 2,000 millivolts. But it still produces the same powerful contraction. So if it still produces the same amount of tension and the same amount of contractile force, well then there's nothing different with me shocking it at 1,000 millivolts versus 2,000 millivolts. This must be my maximal stimulus. So 1,000 millivolts, let's just suppose, is my maximal stimulus for this muscle cell to produce the most powerful force or contraction on this actual muscle cell. So let me explain it one more time. I hit it with very little voltage. No observable event occurs. That must mean that it didn't reach threshold. So it must be subthreshold. Where's my black? There it is. Subthreshold stimuli, or stimulus, right? If I hit it at threshold and it produces the first observable contraction, that must be threshold. But if I jack that sucker up to 1,000 millivolts and it produces a very, very powerful contraction, but then I jack it up to 2,000 millivolts and I give it the same voltage, I give it a different voltage, but it still produces the same contraction force, then this must be my maximal stimulus. I can't go beyond that point. Because no matter what, even if I increase the voltage, it's still going to produce the same amount of contractile force or tension. Okay, let's explain that now, taking this concept and applying it to this graph here and this graph. Okay? So first thing we said, let's say with the first event, let's say here I put 2 horizontal asymptotes. Okay? Let's actually say here is this one here. Let's say that's my threshold stimulus. So this is threshold potential. So threshold potential, or we can say, since we put stimulus there, we can also put that, we'll put that in like a little parentheses. So this is the stimulus. So at that point, if you reach threshold, that'll produce the observable contraction. So let's say that a muscle cell is here at this point in this solid pink line. Let's say that that's resting membrane potential. So I'm going to put RMP, resting membrane potential. Okay? And I hit it with that voltage. I hit it with the voltage of about, we said 10 millivolts, right? Nothing happened. So in other words, if we were to draw that one, let's say that we do that one with green. I hit it with the actual 10 millivolts. And it went up and up and up and up, but it didn't hit the threshold potential. What will happen to it? All right, it'll go back down to resting membrane potential. But then, let's say I hit it with 30 millivolts. If I hit it with 30 millivolts, what will happen? We're going to draw this one now. 30 millivolts. Oh, it reaches threshold potential. If it reaches this threshold potential, then it's going to generate some tension. It's going to generate some contraction. Okay, cool. Then let's say it comes back down and relaxes. Then let's say I hit it with 1,000 millivolts. I blast this thing with 1,000 millivolts, and it goes way beyond the threshold stimulus, way, way beyond that potential. And it goes up to another horizontal asymptote. Let's say I come across here. And this is the maximal voltage that you can hit this cell with. So it's the maximal stimulus. The maximal stimulus, or the maximal potential, right? So the maximal potential or the maximal stimulus. Beyond that point, I can't go. I can't go. No matter how much more voltage I hit this sucker with, nothing's going to happen. So I'm going to reach this maximal potential. And then again, like every muscle cell, it has to go into a relaxation period. Okay. So now that we know that, if that's the case, then let's see what this corresponds to on this graph. Because these two we're just going to take, okay, let's see how voltage, the strength of the stimulus, affects tension now. Because that's all we're doing here. Okay, so let's say here's our tension. And let's say that this point here, we come back here and we make this horizontal asymptote here. This point here corresponds to this point here. So it's not maximal potential, it's maximal tension. So it's the most force that the actual muscle cell can exert. So it's the maximal tension. Okay? Look what happens here. This is super cool. Now, let's say, for example, though, I hit it with, I kept hitting it with, the 2,000 millivolts, whatever. If I were to show that next one, look what happens over here. Now I'm going to show this tension aspect. Let's say that this one, the tension, it comes and it rises here. So it rises, has a little bit of tension. Oh, I'm sorry. No. Let me rephrase this. If this is sub-threshold, will it produce any tension? No, because it didn't reach threshold. So if it did not reach threshold, it won't activate an action potential. Sorry about that. So this should be a straight line. No tension developed here. But then, in the next one, we hit it with enough voltage to get it to threshold. What should happen? Okay, well, it hits threshold, generates an end plate potential, generates action potential, muscle contracts. It should generate tension. So I should see a little peak here. So what should happen now? I should see a peak at this point. It doesn't reach maximal tension, but it does increase in tension on the y-axis. And then what happens? It eventually goes back down to relax. Then let's say I hit it with the next one. So this was the sub-threshold. This is the one where I reach threshold. But then let's say I hit that sucker with 1,000 millivolts. What's going to happen? It's going to rise to that point. And it rises to this point here and reaches maximal tension. And then it drops back down. But watch what happens here. I want to explain one more thing. Let's say, for example, I use that last example and I hit that sucker with 2,000 millivolts. Even though I hit it with 2,000 millivolts, which might go beyond, you hit it with that potential there. Let's say I go a little bit beyond that point. I hit it with as much voltage as possible. If I hit that sucker with as much voltage as possible, what's going to happen? So the voltage is a little bit higher. It might even be a little bit higher than the maximal potential, the maximal stimulus. But I told you we cannot go beyond this tension point. We can't. So even though I'm increasing the voltage, guess what's going to happen to the tension? It's still not going to go beyond that tension point. So what's going to happen here? Even though it's a stronger voltage, it's still going to produce the same tension. Okay? So let me explain this one more time, and then we're going to move on to this last thing with the motor unit. Again, if I take this muscle cell here, And the first thing I do is I hit it with 10 millivolts. It reaches subthreshold. It will not produce an observable contraction. No tension will be generated. Second thing, I hit it with enough voltage that it actually is going to generate the first observable contraction. That's threshold stimulus. Then I increase my actual voltage. And I go from that, I go to 1,000 millivolts. If I go to 1,000 millivolts and I hit this muscle cell with 1,000 millivolts and it produces a very, very powerful contraction, generates a lot of tension. But then I hit it with a voltage even greater than that one. So let's say I hit it with 2,000 millivolts. And it still produces the same powerful contractile force. Even though I hit it with 1,000 millivolts, it generated a very powerful contraction. Let's just say, for example, 100 newtons. That was the amount of tension that it generated. But then I hit with 2,000 millivolts, and it still generates 100 newtons. If it generates 100 newtons when it gets hit with 1,000 millivolts versus 2,000 millivolts, that's interesting, right? And that's because maximal potential, right? If you hit this maximal potential, even if you go above it, even if you hit it with more voltage than normal, it still will not change the maximal tension point. Maximal tension is released, is hit whenever you reach the maximal stimulus. If you go beyond the maximal stimulus or the maximal potential, it's not going to matter because it's still going to hit this threshold point for maximal potential. Once you go beyond that, it doesn't matter. So if you hit it with more voltage than is necessary, it's not going to matter because all you need is that maximal stimulus to produce this maximal tension. Okay? All right, so that's that part. So we covered the strength of the neural stimulus. Now, one more thing I got to talk about the strength of the neural stimulus here, and it's related to this motor unit. And what do we say a motor unit was? It's a motor neuron and all the muscle fibers that is being supplied by it. Let's say I take a look at these fascicles now, and we apply this concept with these fascicles. This is a whole muscle, all right? And let's say, for example, that it's the muscles of my arm. Okay, it's the muscles of my arm. Let's say first thing I want to do is I want to be able to, let's say I have a friend named Vincenzo, okay, a friend named Vincenzo, and he's got to give me my money, okay? And if I come over to him, I say, hey, Vincenzo, you got my money? And he says, yeah, I got your money. I'm going to give him a pat on the cheek. Give him a pat on the cheek. Hey, good job, Vincenzo, right? Thanks. Now, if I'm doing that, I'm just giving him a tap on the cheek. Am I utilizing a ton of motor units? No, because motor units, so let me write this down, this relationship here. The greater the motor units, like the motor unit recruitment, the greater your motor unit recruitment, the greater the actual tension or contraction, okay? So this is for being able to carry out more profound, heavier types of loaded reactions. If you have less motor unit recruitment, this is very, very weak contractions, okay? So this is for weak contractions or fine movements. So it's for very low tension and low contraction, or very weak contraction, very strong contraction. Okay? Another thing is this is for very low fine-tuned movement, and this is for very high fine-tuned movement. So for example, like I was explaining, I can use my same hand, the same hand that I can give Vincenzo a nice little pat on the cheek for giving me my money. If he doesn't give me my money, what can I do? Whoop-pa! I can give him a slap, right? That same hand, I could give a pat on the cheek, but I could also deliver a very powerful blow. That's utilizing different motor units. So if I only utilize a very little motor units, that's going to be for very weak, fine-tuned movement. But if I want to be able to deliver a very powerful blow, I'm going to have to pull up a lot of motor units. A lot of motor units will recruit more muscle fibers. More muscle fibers contracting means a greater force and more tension to Vincenzo to make sure that never happens again, right? That's the whole concept here. So if we compare this right here, let's say that you actually, the actual tension is increasing, right? And if tension is increasing, what's happening to the actual muscle fiber recruitment? So you start off, let's say that in this one here, this one right here, it only generates a little bit of tension, not a significant amount of tension, but it generates some tension. Let's say that in this muscle, this whole bundle, I only recruit this many, okay? Just that many. But then I decide, okay, I'm going to hit this sucker with more tension. I'm going to provide more voltage, right? And more voltage, I'm going to have more maximal stimulus, and I'm going to have more maximal tension. What's going to happen here? I'm going to activate tons and tons of actual muscle fibers. Okay? That's the whole concept here. So if you look at this, just hold this whole fascicle here. Carrying out a very weak activity only recruits very little muscle fibers. But if you're carrying out a very, very heavy activity or something that's going to require a lot of force, a lot of contraction, a lot of tension, it's going to recruit many, many muscle fibers. And that's what we're going to talk about, how we do it individually. Because it goes based upon what's called the size principle. Let me write that down real quick. Last thing we'll talk about is the size principle. Okay? So let's say first off, I have this here in time and tension on the y-axis again. Let's say for the first activity, I only want to, tap Vincenzo. Give him a little tap, right? If I only want to give him a little tap, let's say that I do this in this maroonish color here. What you're going to notice is you're going to notice it's going to increase, right? It's going to increase, and then it's going to reach this actual plateau phase, right? And then it's going to come back down, right? So let's say that's the first one. So let's say that this is the one where you're actually going to exert just a little bit of force. Nothing crazy. You're not at maximal tension, but you're increasing. This is the first order recruitment, right? This is going to recruit your smallest muscle fibers. Smallest muscle fibers. Now, I want to talk about why, but I will in just a second. Okay? So this will recruit your smallest muscle fibers. Okay? Okay, so let's say for a second, I'm just going to erase this tiny little part here. I want to add in another little peak point here. Okay, so let's say that I come down here a little bit with this one. Obviously, it's not perfectly symmetrical, but that's okay. And I add in another one, but it's a little bit higher. It's right here. It's not at maximal tension, but it's still increasing. It's a little bit higher than this one. So let's say that this was number 1, and this is number 2, and this is the third one that we'll call on. And this would still be number 3 here also. Okay? Now watch what happens. First thing I did was I recruited the smallest muscle fibers, right, for very, very weak contractions. So this would be smallest muscle fibers recruited would be for very weak contractions, for very fine-tuned type of movement, like giving a little pat to Vincenzo on the face, right, saying good job, Vincenzo, right, that kind of thing. Now, first thing I want to ask you is why is this smallest muscle fibers recruited first, besides it's being utilized for weak contractions because they don't generate a lot of force? Why, though? It's because these ones have the most excitable motor neurons. So these have the most excitable motor neurons. In other words, their threshold potential that it takes to stimulate these guys is a lot lower. So they have a very low threshold potential. If they have a low threshold potential, they'll reach threshold a lot quicker, right? And they'll contract a lot quicker. So these contract very quick, right? So these are very quick at being contracted. So these are recruited first for one reason is they only can generate a little bit of force. Second reason is they're most easily excitable because the motor neurons are super, super excitable because they have a very low threshold potential. So in other words, if you were to compare, let's say just for a quick second here, had to get a chair, guys. Sorry, my knees were killing me. All right, so let me erase this real quick so we can have a little bit more room here to explain this well. Because I don't want to just say, oh, low threshold potential, not explain it. I want to just give a little quick explanation of it. So let's say here I have a graph, right? And let's say here's voltage, and we'll put it in millivolts. And here's time in milliseconds, right? And let's say here's resting membrane potential at negative 90 millivolts. And let's say that I have here, this point here is my threshold potential, okay? Normal threshold. Let's say it's approximately about negative 55 millivolts, okay? And let's say, what did I say? I said we decrease the threshold potential. So let's say I take here in green, and I change it now, and I make another horizontal asymptote. And I have new threshold potential, a lot lower than negative 55. Which one would it be easier and quicker to get to? Would it be quicker to get to this one or quicker to get to this one? That's an easy question, right? I mean, obviously it's going to be quicker to get to this one. So if it gets to this one quicker, wouldn't it reach threshold a lot quicker and therefore it would contract a lot faster? Yes. Okay, so that's one reason why these muscle fibers are recruited first. Okay, one, smallest muscle fibers are recruited because not only do they generate very weak contractions, but also the motor neurons innervating them are very, very excitable. They have a low threshold potential. Okay? Now, let's say I want to generate some more tension. I'm going to recruit in the next muscle fiber, which we have here in purple. Now let's say that I take this one here from this graph here from the tension, and I correlate it to this one here for a single muscle fiber. Okay, now you'll notice, let's say I come from this point here, and I go up a little bit more. Actually, since we're doing this in time, let's carry this one off over here. So let's carry this one off over here. Let's say this is happening in a timed manner. And we notice, okay, the tension's increasing. All right, cool. So the tension increases, and then again, it goes back to this point here. Okay, well, if I'm trying to be able to, again, how are we comparing this? The first one is I'll give Vincenzo a little pat. Then let's say I give him a little, good slap, okay? Doesn't require excessive amounts of tension, but it's going to hit him pretty good, right? And again, where would my horizontal asymptote be? Let's say it's about right here. And that horizontal asymptote is representing maximal tension. Okay, if I try to hit him with a decent amount of force, I'm going to recruit, next thing, I'm going to have the second recruitment order, right? Now I'm going to recruit more of the medium-sized muscle fibers. So now I'm going to recruit the medium-sized muscle fibers, right? And what is that going to do? That's going to help to generate a little bit more contraction force or tension, right? So in this case, it generates some moderate contraction. What else did we say? Not only is it going to generate some moderate contraction, these ones are not going to be as excitable as this one. So it's going to get recruited later or second because the threshold potential of the neurons innervating this is a little bit higher, okay? Has a little bit higher of a threshold potential. So if it has a little bit higher of a threshold potential, let's actually say moderate threshold potential, just for the sake of it. Moderate threshold potential, TP, right? Then it's going to reach threshold a little bit later than this one. So that would reach the actual threshold and it would get recruited second. Then, let's say I'm mad at Vincenzo and I'm giving Vincenzo the whap of his life. I'm like, get the glove, all right? And I smack him. I have to generate a lot of tension, a lot of force. Let's say it's the maximum amount of tension that my arm can generate to be able to do that. What will we see here? We'd see it right here. So let's say that we follow this time axis here, and we go up and we reach the maximal tension point, okay? This would be the third one to be recruited. And since it's the third one to be recruited, what would you expect for this one? Well, this one was the smallest muscle fibers. This one's the medium-sized muscle fibers. This one has to be the largest muscle fiber size. So this one has the largest muscle fibers. Also, it can generate the greatest contraction. And this should be self-explanatory, right? This should make sense. And the last thing is its threshold potential might be a little bit higher than normal. Now, we've applied that concept of motor unit recruitment, right? So this is multiple, what we call this whenever we're summating all of this activity here, these maximal potential stimuli with the maximal tension. When we do that, we're recruiting multiple motor units and we're summating them to produce a very, very powerful contraction, right? So they call that recruitment or multiple motor unit summation. So we can call this, let's do this in black, multiple motor unit summation or recruitment. All right, so you can call it recruitment or multiple motor unit summation. And again, this multiple motor unit summation or recruitment summation is due to the strength of the neural stimulus, the variation in the strength of the neural stimulus, okay? And if the neural stimulus is very strong, it's going to produce maximal tension. If it's very weak, it'll produce very small tension. And again, if you're trying to have tension, very low tension generated, you'll recruit the smallest muscle fibers first because they have a low threshold potential and easily excitable neurons. And they also generate the weakest amount of force. Then if you're trying to do something that's going to require a little bit more force, a little bit more tension, you'll recruit the second order, right? And that will be some of the medium-sized muscle fibers, which have a moderate threshold potential, and they generate a moderate amount of contractile force or a moderate amount of tension. But then if you're trying to be able to lift something very, 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 very heavy, for example, I'm trying to get my gains and I'm trying to curl a lot of weight, and I'm trying to be able to lift something very, very heavy, I'm going to recruit the largest muscle fibers. Okay, so if I'm trying to lift a weight, what's the first muscle fibers that I'll recruit? First one will be the smallest. Then I'll recruit the moderate size or the medium size. And the last ones I'll recruit is the largest size. Because the largest ones generate the most tension, but they're the least excitable neurons. So the neurons are the least excitable because their threshold potential is a little bit higher than normal. Okay? And again, taking that concept and applying it to this whole muscle, this was just taking one fascicle, I could apply that concept to all of these fascicles. So again, if I'm trying to generate, let's say I'm trying to generate a minimal amount of tension, I could activate these guys, right? But then I'm trying to generate more tension. As I try to generate more tension, what am I going to do? I'm going to activate some of the moderate size ones. And then if I'm trying to generate maximal tension, I'm going to activate the largest ones. And that's going to happen with every single one of these fascicles, okay, which are consisting of multiple muscle fibers. All right, so Ninja Nerds, we covered a lot of information within this muscle mechanics. I really hope it all made sense. I hope you guys did really enjoy it. I hope it helped. I really do. If it did, please hit this like button, comment down in the comment section, and please subscribe. All right, Ninja Nerds, until next time.